This experiment deals with the gay Lussac law,
which is P1T2 equals P2T1 when P stands for pressure and T stands for temperature.
The materials we're going to be using today is a thermometer, some tongs, a stove, a soda can, 3 tablespoons of water, a bowl, some cold water, and ice cubes.
Place 3 tablespoons of water in a can.
Now we are going to fill up the bowl with cold water and ice cube, which as you can see we already did.
Heat until you see steam coming out of the can.
Okay, so now we're going to turn on the stove.
Waiting, we're going to watch some Zumba dancing.
David, my husband, business is buying houses, fixing it. So he knows, he's very efficient all the time. Remodel the bathroom.
Okay.
And we're back.
Now we're going to take the temperature of the can.
The pressure that we're going to be starting with is 1 atm since we are at sea level pressure, which makes it just 1.
As you can see, the temperature got to 244 degrees Celsius.
Now we're going to stick the hot can into the cold water.
Going?
Now we're going to take the temperature of the water with the cold water. Okay, and as you can see, our cold water is at about 5 degrees Celsius.
In this experiment, the pressure and temperature are directly proportional, which means that when one goes up, the other must go up, and if one goes down, the other must go down.
When the temperature of the can decreased, the pressure also decreased. So now we're going to plug in the numbers into our formula, and we're going to find the missing pressure number 2. We're going to plug the numbers into the formula to find out what is the missing pressure. So our formula is P1 T2 equals P2 T1. And we're going to put in the stuff we already know. So we know that the starting pressure was 1 atm. And the second temperature was 5 degrees Celsius. So to convert this to Kelvin, we're going to add 273 to make it into 278 Kelvin. And then the pressure number 2 is the one we're missing, so we're going to put an X. And the starting temperature was 244 degrees Celsius. And so we're going to add 273 to make it Kelvin. So it gives us 517 Kelvin. So now we're going to plug it into our formula. So it's going to be 1 times 278 equals X times 517. So it's going to be 278 equals 517X. So we're going to divide both sides by 517. And once we plug it into our calculator, we get around 0.5377. So we can round it. We can round it and say that pressure 2 equals about 0.538 atm.
Action.
Today we're doing the combined gas law.
This is the formula that we're going to be using, where P stands for pressure, V stands for volume, N stands for moles, and T stands for temperature. We crossed out the end because it stays the same throughout the whole experiment, so we don't need to worry about it.
Today we're using a lighter, a measuring cup, colored water, a candle, modeling clay, and a plate.
The first step, which we already did, was to put the clay in the center of the plate, the size of around the baby turtle, and place the candle in the middle.
Place a cup of water with 3 drops of food coloring and mix it together in the cup.
Now we're going to slowly pour the water into the plate and then light the candle.
Place the cup over the candle.
As we put the cup over the water, you can see there was no water because it still had pressure. But as the candle continues to stay lit and eventually goes away, it creates a partial vacuum which sucks the pressure out and causes water to come in.
The candle heats the air and expands it, which prevents the oxygen in the cup from escaping temporarily. And once the oxygen escapes, the candle goes out and the air cools. This causes the volume of the air to decrease and the water to rise. Thanks for watching! I don't know what we're supposed to say. So here's the combined gas law equation we mentioned earlier in the experiment. P1 times V1 over T1 equals P2 times V2 over T2. So our first pressure is 1 atm, the standard pressure. Our first volume is 0.425 liters, the volume of the air in the cup before the experiment. T1 is 292 Kelvin, the temperature of the air in the room. Our second volume is 0.41 liters, the volume of air left in the cup with the water. Our second temperature is 298 Kelvin, the estimated temperature of the cup after the experiment. Our second pressure is what we're trying to find. So you cross multiply, divide by 119.72 on each side, and our answer is 1.06 atm.